Hello everybody, I'm Francesca Giannetti and I work in GeoLab, the laboratory of forest geomatics at the University of Florence. And this study is starting 3 years ago when I start my PhD. And we want to test if structure from motion photogrammetry is able to detect timber extraction trials and classify it, and classify also the changing in soil due to the traffic of heavy machine. Forest operation are recognized from all over the world as a source of soil disturbance, and the heavy machine that are already used in most of the part of the world, especially in the north, are now starting to use also in Mediterranean area, where a slope is a relative height comparing to the north. So we want to estimate if these heavy machines have a huge impact on soil, also to quantify if there is a loss of soil, erosion, something like this. In the context of precision forestry, 3D technologies are recognized as the most important data to quantify a lot of different types of ecosystem service, from soil to growing stock and something like this. In this part, we investigate the potential of local site, so ultra-high resolution in 3D data deriving from human and from drones. Usually, in the context of trials, logging trials, the most simple way to detect the soil impact was to collect a simple profile using a total stations. So we can have the information only in a simple size of a profile. But we think that having a spatial resolution of these trials with information could be very important for forest management and to restoration of these trials. So forest managers are asked to reduce the area of traffic by forest operations, so they need the information to create a route, many streets due to dump traffic everywhere in the forest, control the forest area, so if we want to know where forest operations are, if they respect the regulation, the area, and also calculate if this forest operation have impact on erosion or compaction in the soil. So we investigate the useful of structure from motion photogrammetry for assessing soil disturbance in 2 ways. The first way was to use close range photogrammetry, so we collect data from ground with a camera mounted on a pole of 3 meters. And the first area was one destroyed by a windstorm, so it was not possible to detect the area with a drone before. So when they start to move the stem from the ground, we select 2 trials where traffic from 2 different forest machines, one was the skidder and one the forward, that are similar in slope and in length. So we collect 3 types of data before logging operation, when just they move the first stem from the ground, and after 7 days from the start of forest operation, we are not able to count, in this case, the passes of this machine, because we cannot stay in the logging area, and the end of forest operation. So we acquired this data with a reflex camera mounted on a pole of 3 meters, with this scheme of acquisition using nadir and vertical images in order to collect all the 3D information about soil. And we put 4 permanent ground control points that were not moved in order to co-register different models from different times. And we elaborate the images using photoscan and permanent ground control point and some other ground control point that were acquired with the total stations. So we just made a simple map algebra in order to quantify the displacement and the bulges and the route of the traffics. And we saw that the first passes were the most dangerous for soil. The difference between the two models is really high, where in the second part, from the half of the logging operation to the end, these bulges and the root does not increase a lot. Then, with the Swedish University of Agriculture and Life Science, we made another study in a control area where we can count the passes of a forward. So we was able to also to compare the data with the one derived by total stations. So we create the model in each times, every pass, and we quantify the bulges, the root, and also the volume that was lost or was moved from the trials. Then we say why we cannot pass from close-range photogrammetry through UAV images. Then this was another point of view. So the first thing was that with UAV photogrammetry, it was not possible to collect the digital terrain model before logging operations because of the ground cover or the soil. So we cannot apply the same methodologies that we apply with close-range photogrammetries. And you can say you can use LiDAR, okay, but not all Italy is covered by LiDAR. So we would like to improve our methodologies also where LiDAR is not available. Where LiDAR is available, we can make a really easy change detection between digital surface model. So we can acquire only the data after logging operations. This study was done in a coppice forest, so it's the most useful, the most important forest system in Italy. Most of the forests are managed in this way. And this area was trafficked by a tractor, that is the most used machine in our territories. And we acquired them in the context of Fresh Life project in one of our study areas, the one of Rincine, two different digital elevation models. The one before logging operation and one after logging operation. We acquired the data with a SenseFly EB with an altitude of 140 meters above sea level, no, above ground level, sorry, there is an error here, with an overlap of 75% and side lap of 65% in order to create a very dense point cloud and derive a really accuracy digital surface model that is 20 centimeter resolutions. So we elaborate this data in order to obtain a point cloud digital elevation model orthomosaic using ground control point acquired with a high resolution GPS that was corrected with the nearby local station, GNS local station. And we create an automatic procedure in order to detect trials in logging areas. This is really important in order for forest manager and authority control, because if the trials are not distributed in the area with distance between each other, and if the tractor traffic all the area, we can have a lot of problem of regeneration of forest, and also a lot of problem of erosion. So for the authority that needs to control logging area, it's really important to know this aspect. So we made the first digital elevation model, and the digital elevation model after logging operation, we made a easy change detection in order to automatically classify the logging area. So we can track automatically the boarding of logging area. And moreover, it's possible to detect the island of trees that remain in the coppice, we call matricine. And so subtracting this area, we can know the area of interest that could be interest from erosion or something other problem related to soil with an high accuracy. Moreover, if we use the digital elevation model of time 2, so after logging operation, with a threshold on the slope, we are able to detect automatically the trials of the logging operation. So for the authority that need control these things, this is a really important application because usually they need to work all this area and maybe they can lose a part of it. But this, with the drone, they can have a really high resolution image of the logging area. If they are not able to do this with this automatic procedure because it's quite time-consuming programming, however, they can do with orthomosaic. That is really easy to detect, and they can show in this area that sometimes was wrong because the tractor traffic everywhere. So it could be possible that there was some problem of regeneration of forest. And moreover, it could be interesting to acquire new data to detect if there is some erosion problem, if the vegetation doesn't cover the trials. So we can say that closed range photogrammetry, structure for motion, is really useful to quantify soil damage caused by forest operation. And also UAV structure for motion photogrammetry is useful to automatically detect the forest area and the trials. However, with UAV photogrammetry, it's not possible to detect the DTM before harvesting, so we cannot calculate the volume of forest soil lost, as in the case of closed range photogrammetry. So the next step will be to combine closed range photogrammetry with UAV photogrammetry in order to detect the volume lost and the root of soil. That is really important. So thank you for your attention.
Thanks a lot for your presentation. I wonder if there is any question from the audience. One question from my side. Did you carry out any accuracy assessment on the detection of the logged area?
Yeah, because usually the logged area is acquired by GNS receiver. So the accuracy is the one of usually that you have is the one of GNS receiver that usually are not the topographic GNS. And for the model, we use the ground control point measured with a topographic GNS. So I think that the model derived by structure for motion is more accurate comparing to the one that usually is used by authority to detect the logging area. Yes, but we had some measure on the ground control point with the two different system of GNS, and we saw that usually the authority have 1-2 meters on the border of error, while with some point measure with the top corner double code GSNS, we have it's a really small error. It's 10 centimeters that usually in forest is a normal error. We don't have much small error. 10 centimeters is nothing in forest. For topographic, it's really different.
Yes, please.
Not question, just comment. I believe that in maybe 2 or 3 years, there will be also some autonomic machines in the forest.
Yeah.
Not only robots, but also such forwarders or skidders. So there will be scanners available on the machine.
We know
cameras
that.
on the machine. But still there will be some limitation, even if you will use EMU on board, because, for example, of water staying in this damaged areas, damaged part of roads. We done similar study like you, but without UAV, but I scanned 300 to 400 meters of the road by a terrestrial scanner.
Yeah, we have published also with the
but the problem using a handheld camera was the branches. Branches and leaves and branches, the whole stuff laying on the road. Because it's not easy to remove to filter this, so it's much better to.
We remove manually because the length was really.
Before the harvesting.
This could be problem. The branch, we remove it manually in the first study because there was only 20 meters of length so what's really easy to remove them. But in operational way, yes, they could be, they can be the source of mistakes in the estimation of volume.
Good. Thanks again.